Welcome back, class. When we were last together, we talked about inference and observation. We defined both, compared them, contrasted them, and talked about their importance in the scientific method. Today I'd like to talk about the characteristics of science. And there are 5 different characteristics I would like to address, and show you a couple of video clips to demonstrate one of them. The first characteristic I'd like to talk about is how science is based on the assumption that the natural world can be investigated and explained. That's a very important belief shared by scientists. It's the belief that we can make sense of this incredible world we live in. It's not magic, it's not voodoo, it's not witchcraft. There's an orderly process to our natural world, and we're learning about it each and every day. And it's this belief that we can learn about it that powers the other characteristics of science. Second characteristic. Scientific work is based on the results of controlled experimentation and observation. It's not some haphazard collection of data. There's a process that scientists go through. And to be recognized work within the scientific community, your experiments have to follow a scientific method. And we'll be talking about that later in the unit. Another characteristic shared within science is that your work must be repeatable and verifiable. If you're going to make some type of scientific claim, other scientists will need to be able to test your results and to analyze your hypothesis and verify it to make sure that it's accurate. Going hand in hand with that is sometimes science has to be disproven or refuted over time. Hypotheses can be accepted and rejected. That's an important part of science. If a hypothesis is wrong, that's not a bad thing. It's been proven wrong because we've acquired more knowledge, which is an important part of science. So scientists can change what they've learned over time. Our view of the atom is not the same as it was 50 years ago, 100 years ago, 1,000 years ago. It's changed over time. Older theories have been refuted and disproven, and more modern theories have been adjusted and changed over time to reflect changes in technology and our ability to learn more about the environment and our natural world. Another characteristic of science is that it's an ongoing process, like I mentioned with the model of the atom, how it's changed over time. Our view of the universe has changed dramatically over time as well. A great example of this is DNA evidence in forensic science. DNA evidence collection, use in crime investigation, that skill has changed dramatically in the last 30 years, which makes you wonder how many people throughout the history were wrongly convicted of crimes because there was no technology available at the time to prove their innocence. That's rather sad. But continual developments in scientific technology has made the work of forensic scientists and police work far more accurate. And a great example is the West Memphis 3. These 3 fellows were erroneously convicted of murder back in the early 1990s. Unfortunately, at that time, DNA collection and analysis was not nearly as accurate as it was today. Fast forward to 2011, new technologies in the collection and processing of DNA led to the acquittal and release of the Memphis 3. I'd like to show you a great example of what I'm talking about here in science is an ongoing process. I want to show you 2 video clips. The first video clip I'm going to show you is a crime that took place 200 years ago. I'm going to show you how the sheriff was able to solve that crime using only the technology he had available at that time, and how skeptical you might be after watching that video as to the guilt of our suspect, because there's so little evidence to prove his guilt. We'll see the crime, but the lack of evidence is very concerning. And then we'll fast forward 200 years later and see all the modern technology that forensic scientists have to put together a very, very strong case, taking our observations and turning them into very accurate inferences. So let's watch part 1 together first.
As you watch this segment, think about how investigators collect, store, and analyze evidence from a crime scene, and what they are able to infer from observations, new data, and additional evidence. Forensic science has become a cornerstone of crime solving. It is almost impossible to commit a crime without leaving a trace. And forensic experts can use even the most minute of these clues to identify a criminal. But this was not always so. Before modern scientific advances developed, crime solvers relied on confession, eyewitness accounts, and the most obvious of clues. 200 years ago, John Toms had a business dispute with his neighbor. Enraged, he vowed to get revenge. Toms carefully loaded his pistol, first with gunpowder, then with a wad of paper torn from a song sheet to hold the gunpowder in place. He placed the rest of the song sheet in his breast pocket. Toms made his way to the neighbor's yard, where his target was strolling. He aimed, fired, and hit his mark. Then he approached his victim. While bending over, the wounded man grabbed hold of Tom's sleeve for a brief moment before he died. Toms quickly ran away. The sheriff came to investigate and quickly found the clues that led him to suspect Toms. He found on the victim the wad of paper Toms used to secure the gunpowder. When the sheriff's men questioned Toms, they found the rest of the song sheet just where he left it, in his pocket. Quickly, they were able to match this paper to the wad removed from the crime scene.
Take him away.
And Toms was arrested. He was tried, found guilty, and hanged for his crime.
Pretty frightening, isn't it, to think that people could have been tried, convicted, and possibly even executed on that little bit of evidence. Luckily, science is an ongoing process, like I said, and technologies, processes, all these develop over time and get more efficient, more exact, overall better. So I want to show you the same crime scene 200 years later. Look at all the observational evidence that the forensic scientists can use this time to make a much stronger case and a far greater inference as to who the guilty party really was.
In the last 200 years, detectives have come to rely more and more on forensic evidence. Today, with modern scientific tools in hand, this investigation would be handled quite differently. A scientific method would be employed using observing, inferring, predicting, and modeling. Based on this information, scientists would develop a hypothesis about who the criminal was. Toms left a slew of clues that modern forensic experts could use to link into the crime. Even if John Toms had burned the song sheet and made efforts to disguise other clues, experts would still have plenty to go on. First, they would secure the crime scene to protect any evidence. They would also take photos of the entire scene. Then, forensic investigators would take the temperature of the victim to determine the time of death. This data would help scientists form a hypothesis about the identity of the criminal.
Body temperature 18 degrees C.
Detectives would systematically comb through the crime scene for other clues, collecting other data. A footprint that Toms left in his escape would be cast in plaster, which would show that Tom's boot matched perfectly, down to a chip on the heel. Continuing to collect data to support or refute the hypothesis, the forensic team would examine the body for hair or other evidence. They would look under fingernails for bits of fiber. Collected with adhesive tape, the fibers would be taken to the lab for analysis.
Can you remove your coat and put it in the bag?
The team would gather clothing from the suspect, to compare to fibers found at the crime scene. The fibers in Tom's vest make a perfect match. Blood on the victim's hand would lead detectives to believe that they would also find the victim's blood on the suspect. Tom's blood-stained shirt would be collected and analyzed. In the lab, scientists would use DNA analysis to test the blood on the shirt and compare it to the victim's. Because each person has a unique DNA code, the results of this kind of test are generally conclusive. The blood on Tom's shirt would definitively match his victim's. The gunpowder Tom's used would also provide clues. It leaves a residue on the hands and face of the shooter. Samples from the victim's wound and swabs from Tom's face would be analyzed in a crime lab. Using a technique called chromatography, which separates chemicals in the gunpowder, samples would show that there is a perfect match. Forensic scientists would now form a conclusion based on the data collected. The mountain of evidence would conclusively pinpoint Tom's as the culprit. Despite Tom's best efforts to disguise the clues, modern forensic science could detect traces of evidence beyond what is visible to the naked eye. Today, using tools that were unimaginable 2 centuries ago, scientific proof would convict Tom's, beyond a shadow of a doubt. How much more evidence would modern investigators have about Tom's than investigators from 200 years ago?
I like those 2 video clips because they, juxtaposition together, give you a great viewing as how technology has changed over the last 200 years. And you can see how science is continually developing. It's an ongoing process. And who knows how they'll be solving crimes 200 years from now in the future. When we meet again, we'll finally start talking about the scientific method itself, this process that scientists go through to understand and explain this incredible universe that we live in.